Some fish have a density slightly less than that of water and must exert a force to stay submerged. What force must an 85.0 kilogram grouper exert to stay submerged in salt water? Its body density is 1015 kilogram per meter cube. So we are given the mass of the grouper. That's 85 kilograms. And stay submerged in salt water. So the water is salt water. Let's call it Rosa base. The density of salt water from table is 1025 kilograms per meter cube. And they are also given the density of the fish. Let's call it rho sub f. And that's 1015 kilogram per meter cube. And what we are asked to find is what force must the grouper exert to stay submerged? That means force exert, let's call it F sub E. That's what we are asked to find. Let's sketch the situation. So if you have a grouper, let's call this a fish. So there is a force downward because of the gravitational acceleration, that's a gravitational force. And then the force, there is a bound force upward. Let's call it F sub B. Since F sub B is greater than mg, the grouper has to exert a force downward. That force is F sub B. And this is what we are required to find. Alright, so now we know that summation of all force must be equal to 0 to stay submerged under certain depth, at certain depth, and that means summation of all force must be equal to 0. Or net force must be equal to 0. That's to mean the force upward, which is F sub B, the bound force, minus gravitational force downward, plus the force that the grouper is exerting downward should add up to 0. So if you rearrange the equation, F sub E will be equal to the bound force F sub B minus mg. Okay, so what is the bound force equals to? We know from Archimedes' principle that the bound force is equal to the fluid, the weight of the fluid displaced. That's weight of the fluid, in this case salt water, minus mg. Alright, so now can we write the fluid displaced? That is the volume of the fish, because submerged object displaces its own volume, multiplied by the density of the seawater, salt water, times gravitational acceleration is the bound force, minus mg. Now, but what is the volume? The volume is equal to mass of the grouper divided by its density, rho sub f. Rho sub s g minus mg. Alright, so now we can take out mg because m and g are common to both terms, therefore mg into the density of the fluid, the seawater in this case, salt water, divided by the density of the fish, minus 1. Okay, let's plug in the numbers. Mass is given 85 kilograms times the gravitational acceleration, which is which is 9.80 meter per second squared, times rho sub s, which is 1025 kilogram per meter cube, over the density of the fish, which is 1015 kilogram meter per meter cube minus 1. That force is equal to 8.21 Newton.